This is horrible.
What's up, math scholars? It's Wednesday. My first period class is so happy to be at school, and they love making videos for everybody to watch to become more scholarly. So I wish you could see them. They're all wearing their purple math scholar shirts. They look so cute. So hey, who's excited that we have a quiz tomorrow? Woo! It's the last product grade this 9 weeks, okay? So if you're hanging out at like a 89, go for the win, go for the scholar pass and get that A in the class. All right. We are calculating out the mean, variance, and standard deviation by hand. Visually, I'm definitely looking for 3 columns. If you don't have the 3 columns in your paper, I know you didn't show your work by hand and you'll get points taken off. All right. Do you remember how to start? How do we find that mean? Add them all up and divide by 6. There's 6 numbers on our list, so let's add them up and divide by 6, and that'll be your mean. All right, we got the sum of 36. Then we divide by how many numbers there are, which was 6, so our average is 6. All right. The second column is your deviation column. It's not your standard deviation. It's just called the deviation. It's how far your number is off of the average. So like how far is 9 from the average of 6? 3, good. How far is 8 from the average of 6? Good. 7, 5, 1, 6. Good. Nothing more to do with the second column. Your third column is the square of the deviation column. So you're just going to square every number you have in your second column. So 3 squared, 9, 2 squared, 1 squared, 1 squared, 5 squared, and 0 squared. This is the column that you will average now. So add up all those numbers and divide by 6, and that will give you our variance. It's called sigma squared. 9 plus 4 plus 1 plus 1 plus 25. That gave me 40. Is that what you guys got? And 40 divided by 6 is 6.6 repeating. So that's your sigma squared, or your variance. And do you remember how to get from sigma squared, which is variance, down to sigma? Square root of 6.66666 repeating. 2.58. Now, do you know how you could use the calculator to check yourselves? You could get this stuff into Stat World. So you would go Stat, Edit, Stat, Calculate 1, and you'd put all this stuff in your L1. And that's a quick way to check that your mean and your standard deviation are correct. It's what you should have done on the project. How many of you guys use Stat World on your project? Everybody should have. It should be 100%. I went around and one group was doing the project and they were trying to get their standard deviation by hand. And I was like, ooh, that's going to take a while. All right, number 2. Use the normal chart picture below to answer the following questions. All right, these questions are kind of hard to comprehend, but they make sense if you know what you're doing. What's the probability of selecting an x value that lives below x bar plus 1 sigma? So you go ahead and you try to find this location. This is a location. X bar plus 1 deviation. The mean plus 1 deviation is right here. So here's the location. We want the probability of living below that. So we need all of those added up. And you can add them up quickly if you realize that from the mean on down is 50%. So what's our answer?
84.
84%. There you go. Any questions on that one? If you know what you're doing, it should be pretty easy. If you don't, it might look confusing. All right, part B. Now we want the probability that my randomly selected x value would be between x bar and x bar plus 3 sigma. So that's the mean and the mean, or 3 deviations above the mean, 3 above. So let's find those locations. Here's the mean. Here is 3 deviations above the mean. So if we want the probability of living in there, we'll add up those zones.
35%.
No, if this is 34%, you're going to add up another 13.5 and another 2.35, which is 38, or whatever you said. 47.5.
Okay, now we know that.
I was right.
Hey, we just checked our math. Our apologies, it's 7:54 in the morning. We checked their math. It's my apologies. 49.85. He was right. He had said 49 originally, and I have ignored him. So look, if you get a ticket, I feel terrible.
If we're wearing a purple shirt, don't we get a ticket? No, you didn't. It's a really short story.
Yeah, I just heard someone say this is a short study guide because these quizzes are only over 2 sections apiece. So that's why we're only doing 1 day of review and moving on. Tomorrow, the Polaris has 11 questions, so 22 points. And then the paper pencil portion, it was somewhere between 20 and 30 points. I don't remember. I made my answer key already, though. You're going to fit the following scenario to the provided normal curve. It's going to be your job to label all these hash marks. So the average housefly's wings have a length of 4.6 millimeters. That's our average. That's our X bar. With a standard deviation of 0.4. So that's going to be your sigma. We have to travel to this curve and label everything. And that's why you kind of did your project where you practice labeling your curve. What would go right here, smack dab in the center? 4.6. That's your average. Now, how will I proceed? Who would be this next hash mark?
5.
5, because you're going to add a standard deviation, so it's 4.6 plus 0.4. What would go right here? 5.4. You added 1 more deviation. And who would live right here? Good, you added 1 more deviation. So you add 3 deviations to the right. All right, now we have to travel to the left from average, so we're going to subtract a deviation. 4.6 minus 0.4. Good. 4.2 minus 0.4. Good. And 3.8 minus 0.4. 3.4. All right, we are labeled and ready to answer some questions. What is the probability that a fly has a wing length of at least 5 millimeters? So there's that pesky at least. So is at least mean 5 and above, or does at least mean 5 and below? At least 5. And I always like to turn it into a situation in the classroom. At least 5 of you will get an A tomorrow. Does that mean 5, 4, or 3 of you will get an A, or 5, 6, 7, and 8 of you will get an A?
5, 4, 3. Right,
so you're going to be going up above. So you're going to start at 5 and add up all the zones above 5.
So much.
16%, I agree. All right, I'm going to erase my markings. Part B. What is the probability that a fly's wings would measure between 3.8 and 4.6? Well, that was pretty easy because they're flat out saying between 4.6 and 3.8. So these zones right here. 47 and a half. That's the one I was thinking earlier. And then, what is the probability that a fly's wings are greater than 5.8? This is a really small space. 0.15%. All right, the guayale plant, which grows in the southwest United States and Mexico, is one of several plants used as a source of rubber. Oh man, I should talk to my husband about this. He's in the rubber industry. The plants have a mean of 12, I'll jot that down, inches, and a standard deviation of 2 inches. Let me jot that down. We're going to find the z-score for a plant that's 9.5. So let me understand here. Find the z-score. We're just going to find the z-score. We're not going to then look at any charts and find any probabilities. Are you clear on that? All right. There was one on the project where it said find your own z-score for your own answer. All you had to do is find the z-score. You don't have to look at a chart. All right. So find the z-score. We're going to use our z-score formula. You take your x value of 9.5. You subtract off the average. And then you divide by the deviation. Just remember to click enter before you divide, and if you refuse to click enter before you divide, put parentheses around the top part. So I do 9.5, subtract 12, I click enter, then I divide by 2. All right, Nathan, did you get negative 1.25?
Yeah.
That's what goes on your answer blank. We're not going to look at the chart right now. I believe part B is where we head to the chart. We want the probability that the plant will grow to a height that's less than or equal to 9.5. So I guess the good news is we already know the z-score for 9.5 is negative 1.2. I'm going to round it to negative 1.3 so that when I go to look at my chart, I can have something I can look at. Our chart only goes to tenth places. So did everybody get a chart out that they can look at it right now?
No.
Okay. Give a second. Get your charts out. Get your z-charts out. All right, so we went to our z-score chart. We're looking up negative 1.3, and that will be the probability of being below 9.5 inches. What did you end up finding on your chart? 0.0968? Okay, so that would be your answer. 0.0968. So just something to remember about this chart is it always gives the probability of being below a certain point. If you need to find the probability of being above or between, it's going to require different methods. I think that's where we're headed on part C and D. All right, part C. What's the probability that the height will be between 12 and 18? All right, let's talk game plan. We're going to z-score the 12. We're going to z-score the 8.8.
And then don't minus those z-scores.
You don't minus the z-scores. You look on the chart for both of the scores, but then you subtract the answer at the very end. So what we have here, think about our normal chart. We're going to find the probability of being below 12. Actually, the average is 12, so you should know the probability of being below 12, right? 50%. I don't even need to do a z-score. But then you'll find the probability of being below 8.8, and then you'll subtract them at the very end. Okay? That's how you're going to get the probability of being between. But just for kicks and giggles, let's go ahead and actually do the z-score. The z-score of the 12 is going to end up being a 0. And that's why it's going to be a 50% chance of being below 0. If you look up 0 on your z-score standard normal table, it's 50%. Now we'll z-score at 8.8. 8.8 minus 12 over 2.
This one's just for
Eight.
giggles.
No, this one we have to do because we don't know where 8.8 is. We knew where 12 was.
Oh, we did?
Did you get a z-score of negative 1.6? Yes or no? Okay, yes. Then I'll look at my z-score chart for negative 1.6. 0.0548. And I'll finish the day off by subtracting these numbers, biggest minus smallest.
The answer was a bigger one.
0.50 minus 0.0548. So it's a 0.4452, so 44% of living between. All right, let's find the probability the height will be greater than. Do you remember a greater than strategy? Yes, so you're going to look z-score the 14.2, find the probability of being below there, and then take that and at the very end subtract it from 100%, because that will give you the probability of being above 14.2. So here it goes. We're z-scoring our 14.2. Let's find our z-score of
What's your
14.2.
favorite snack, like junk food? What?
So we get a 1.1 for our z-score. We're going to look up 1.1 on our little chart, and that'll be the probability of being below that point. Did you get 0.8643? You'll need to subtract that from 100%. What did I say it was? 0.8643? And that will be the probability of being below, or above. It's a no. So I've got on my paper 0.1357. I surveyed shoppers randomly at the mall about how many pets they have and found that my margin of error was 3%. How many people did I survey? We did one like this yesterday in class. So I'm going to set that 3% as a decimal. Very important to write as a decimal, 0.03. I'm going to set it equal to my margin of error formula, which will be provided to you. You don't need to memorize that. And then yesterday we talked that solving this is a 3-step process. Do you remember the 3 steps?
Times square root.
Logan remembers. We times both sides by the square root of n. So that cancels, and it gets it out of the denominator. Very important to get it out of the denominator.
Divide by 0.3, correct?
Good, he remembers that. Step 2, divide both sides by 0.03. I have to grab my calculator real quick.
And then you
1 over 0.03 is 33.3, repeating.
you square root.
No, he said then you square root that. No,
Square it.
then you square it. There you go. Make sure your terminology is correct.
Yeah, come on.
I got 1,111.11111. So that's how many people I surveyed at the mall. I must have been at the mall for hours.
11111.
I think people would think
All right. In a survey sent to 4,000 people, it was found that 80% of them love football. But there's a margin of error, so we're going to find that margin of error. Our margin of error formula is positive or negative 1 over square root n. Now, n is your sample size. How many people did we survey? 4,000. We're on a new problem. We're on the football problem. He's still on the pet problem. Probably because he has his AirPod in.
No, it's because I can't find my snack.
It's 1 divided by the square root of 4,000. So that would be a positive or negative 1.58%. So let's just round that to 2%. You always want to round to the nearest percent. So it's a positive or negative 2% error. Now, do you remember how we did this yesterday? Give an interval that is likely to contain the exact percent of all people who love football. So 80 might be wrong. 80 could be up to 2% wrong in both directions, a positive and a negative direction. So you do 80, you basically do 80% plus or minus 2%. So what's 80 plus 2%? 82. What's 80 minus 2%? 78, and that's your range. That's the exact range that should include the actual number of people that love it. All right, we're in the home stretch, 7 and 8. A survey about pumpkins is given to every 3rd person who walks into school. What type of survey is this?
oh,
I came up with a rule, didn't I? I'm surveying every 3rd person.
Random.
No, random would be like, you're doing a survey, you're doing a survey, you're doing a survey. I don't have a rule, it's random. Systematic, very good. So look over those 4 types tonight, so you just remember them, they're fresh in your mind. Systematic. Would this survey be biased? No, everybody got a chance to be surveyed. Some people that love pumpkins, some people that hate pumpkins. I got a
I
good
mean, if
range.
you're like at a pumpkin farm asking people that, it kind of is.
But I'm at the school, so.
Um,
I wanted to survey people on where they love cats, so I surveyed every person who volunteers at the Humane Society. What type of sample would that be?
it's the convenience one.
Yeah, it'd be the convenience one. I'm only going to one location. I'm not really trying to find a broad range of people with a broad amount of opinions. Then would this survey be biased?
Yes.
Yes, definitely. You want to put your reason. So this one was no because everybody got a chance and I wasn't at a pumpkin farm. And this one was a yes because only pet lovers would be at the Humane Society volunteering. All right, well, thanks for watching our video. We did make it in under 20 minutes. That's good news. Hope to see everybody at a study party. Getting ready for tomorrow's quiz.